Hello and welcome to today's lesson from the GCSE PE portal. Today we're going to be looking at the cardiac cycle. Now I've got two words on here to start with, which are systole and diastole. And I'm going to come back to those later on, but what I want you to be thinking of straight away is green for go and red for no. Because systole means all action and red means all rest. Okay, just be bearing that in mind as we go through the rest of this lesson. So to start with, we do need to get the diagram of the heart on the board. So we'll get our grid, we'll put the septum in, so our two sides, the right and the left, our atria at the top, ventricles at the bottom. So we have the right atrium and the right ventricle, and then the left atrium and the left ventricle. Now when we talk about the cardiac cycle, what we're actually talking about is the sequence of contractions that have to occur in a set order for blood to actually get drawn into the top of the heart and pumped out at the bottom. Because it's a muscle, it's one muscle, and it's got two different jobs to do. It's got to pump deoxygenated blood, if I get my blue pen, it's got to be able to pump deoxygenated blood down and up to the lungs, and it's got to be able to get oxygenated blood down from the lungs and out to the rest of the body. So because we've got two different sides to this one organ or this one muscle, what we call it is a dual action pump. Just put that on the board there. Dual action pump. Dual meaning two. We've got two sides of the heart and we've got two separate pump actions going on. However, this really gets a little bit confusing and clever, because yes, we do have two pumps, but they work in unison, so they work at the same time. And by that, I mean the atria contract at the same time and relax at the same time, and both ventricles contract at the same time and relax at the same time. So yes, we do have two pumps and two separate sides, but the flow of blood through the chambers is symmetrical. The right-hand side flows at the same time as the left-hand side flows. That's what we mean by dual action pump. So I'll come back to these two words which I put at the start, systole and diastole. I said that systole is green for go, because when our heart needs to contract, our brain has to send an impulse or an electrical current towards the heart. Just like electricity switches on lights, we've got impulses which switch our heart muscle on. It makes it turn on, it makes it contract. Now when a muscle turns on, it contracts. Systole is when there's a current or there's electricity or there's an impulse inside the muscle and it's currently contracting. When the muscle hasn't got any of that in it, when it hasn't got current or impulse, it's resting, it's relaxing, it's in diastole. So a muscle, like a light switch, can only ever be, or like a light bulb I should say, can only ever be on or off. Okay, there's no in between. It's either switching on and contracting and it's in systole, or it's switched off, it's relaxed and it's in diastole. So, now that we know that, we now need to work out what our heart does, which parts of it enter systole and diastole and when they enter those stages, in order to get blood to fill up in one chamber, to then empty down into another, to then fill that one up, to then be ejected and leave the heart for good. So we're going to start off up at the top, because it's cyclical in nature, because we've got a heart beats, or our heart is always beating. It's always going. But we'll jump in when the atria are filling with blood. So in order to fill the atria with blood, so the vena cava is bringing blood back and the pulmonary vein is bringing blood back, in order to actually allow blood in, the chamber has to be in relaxation. It has to be in diastole. Because if it was in systole, it would be squashed. There'd be no space, the pressure would be too high and the blood wouldn't be able to enter. So we'll start off with atria diastole. Atria D. Okay, atria diastole, and they begin to fill up. Okay, at this point in time, or just before they start to fill up with blood, the ventricles have just finished contracting. They've just finished their systole phase. but now they're entering diastole phase as well because they've just finished their contraction. So they're switching off and they're beginning to relax, which means blood can now flow down into that bottom half, into our ventricles. So we've got atria diastole at the same time, I'm just going to put VD, the same time as ventricle diastole. So the heart is currently rested, there's no beat. This is the gap between gap, gap, gap. We're currently in the gap. Neither half or neither chamber, or any chamber, is contracting. Then we get the first thud of the heartbeat. That first thud. That's when the atria contract. That's when atria enter systole. So if I put AD, that means atria, no, not D. Atria systole. AS. Atria systole. These top chambers are contracting. They've received that impulse from the brain, that electrical current, switching them on. That muscle contracts and it squeezes blood out from the atria and then down into the two ventricles. Atria, systole. Meanwhile, the ventricles are still relaxed. They're still in diastole. They're ready to receive the blood that's being forced down from the atria down to the ventricles. Once the atria are completely empty, like a sponge, completely squashed, it's completely dry of blood, the valves in between, so the things that block, remember those Lucozade caps I spoke about when I was talking about the pocket valves in veins? These Lucozade bottle cap style valves where as soon as the pressure drops again, they snap back shut, no more blood flow. The valves are closed, the blood is filled inside these ventricles. Now we want to force it out of the blood for good. So the ventricles now enter systole. Ventricular systole. These contract, these switch on, this forces blood out into the aorta, out up into the pulmonary artery, and blood leaves the heart. As that ventricular systole is occurring, we return to the start of the cycle. The atria, which just here was in systole, is now returning back to the diastole phase. When the ventricular systole is finished and blood is ejected from the heart for good, that then switches off and re-enters ventricular diastole. And it goes on and on and on. And that is the cardiac cycle. I hope you found that useful, and I hope to see you again soon.